Good afternoon, everyone. It's great to see everyone for the final webinar of the 24-25 school year. This is my 16th webinar. The rest are up on the YouTube channel. This one I'll get up sometime. And I'm super glad that you could be here tonight. If you're watching the recording, it's great to meet you. You're about to engage in one of my favorite topics out there. My name is Sara Werf. I'm the MDE Academic Standards Math Specialist. If you're attending this live, I can see the chat. I'm not saying I'll promise to see the chat, but feel free to respond along. It makes me happy when people can do that. One of the things you could respond to, although if you've seen this before, don't ruin it in the chat, but whether you're watching the recording or here live, I'm wondering if you can see it. So take a look at this picture. Can you see it? I'll show it to you again later on, but can you see it? So take a look at this, look around. Maybe what you see is a brick. You could put that in the chat. Can you see it? So today we're going to talk about how I realized I titled this a lot of different things, but really what we're going to talk about in this webinar is how you might read or misread mathematical items. And so as you think about yourself and students, some of the things you see below we'll be talking about in this session. But I have some thoughts on how you can support students in engaging in the mathematics sets in the 2022 Minnesota Academic Standards in Mathematics that were just official about a month and a half ago, but also applying to our current standards, 2007 standards. So everything I'm doing, I'm not going to put up all the benchmarks in this webinar, but they're all related to mathematics you'd find in K-12 education in the state of Minnesota. As always, the goal of this webinar is to center the students that will be the most impacted by the things that we as the educators in the system are working on to improve conditions for our students. These are the children of the committee members that wrote the math standards for Minnesota. And one of my favorite articles to read, and I've uploaded it into a folder that you can access, that I reread a couple times every year, is Never Say Anything a Kid Can Say, because my goal is to empower for our next set of students the ability for them to be mathematicians and to decenter myself and empower them to feel independent, to grow. And so all of these reading webinars have been centered around all the commitments to equity, but specifically number 9, improving conditions for learning. As always, I'm sharing everything that you see in this video. A lot of it's already there. I might put a few more links in there over the next week or so, but you can go there live if you want. Hopefully somebody will re-put the link for it in the chat, but the QR code and the bit.ly will get you there as well. I'll be sharing this at the end of the session as well. When you go in there, there are things like PLC protocols. That's the one thing that I need to just tweak a little bit. A lot of links, a lot of resources. There's a folder of articles and a whole lot more that you can do. So can you see it? Can you see it? If you have some ideas, throw some ideas in the chat. Do you know anything? Thank you, Amy, for throwing links into the chat. That's really helpful to me. I don't know how you grew up, but I was a kid in the 70s. This picture was probably in the 80s. It's not of me. It's just kind of represented how I spent my youth. We traveled as a family by car in a lot of places. And one thing that was true is that me and my 2 siblings, we loved maps. We would watch, there was no such thing as cell phones or any other devices. In fact, I know this is not the 70s because there is only cassette tapes. I don't know what was going on with those headphones and all of that, but it does kind of tell the age of the picture. But I want you to focus on the map because I grew up in a time where every time we traveled, in order to get there, we had to use a map, but I loved maps, figuring out where we were going, what was the name of the cities, and so on. That's going to apply to something in a little bit. We were also one of those families who loved board games. This is at my brother's wedding a long, long time ago. There's me. And I learned to play Settlers of Catan in 1996, 1 year after it came out, because Volker was my brother's roommate, and he is from Germany. And at the time, the only way you could get the game was a German version of the game. So I learned on a German version of the game. And I also, years later, when Ticket to Ride came out, the American version was not out yet, but the Europe version was out. And Volker introduced our family to Ticket to Ride. And I don't know if you've ever played this board game, but in this board game, you are building train routes to get from city to city all over Europe. And you get these cards that say you get 20 points if you get from Brest to Petrograd, 7 points if you get from London to Berlin. And then you're trying to put trains on these things. And then you're going to look and find these cities. And there's cities that I had heard of and knew and had visited. And then there were cities on the map that I had never heard of and didn't know anything about. And so the good news is when you looked at these cards, they always gave you clues on the card where the cities were located. I was really excited when the American version of this game came out because in the American version, I'm like, I am good. I'm a kid of the 70s. I know where everything is. I have traveled all over this country. So I was all excited to not have to use all the supports on the cards to do this. So we started playing, and then I immediately looked at the board and I'm like, really? Really? And I realized that there were mistakes on the board, or at least I thought they were mistakes. Like they put Duluth where Minneapolis is. And it was like immediately annoying to me. And to this day, when I play this game, it's immediately annoying to me that Duluth is where Minneapolis is. And I started looking around the board, and sure enough, Chicago was in Indiana, and some other places were out of things. I Googled it. It turns out other people are annoyed by this. And they said on the 10th anniversary, there was a tiny sign in the game board that said, here lies the real Duluth. Why am I telling you all this? Because I started thinking about the European version of this game. I had played it for years. Never once did I think, is one of these cities in the wrong locations? And I bet some of them are. But I never once thought about it because it was unfamiliar to me, and I didn't know how to read the map of Europe like I knew the United States. What I knew that I could do, because I grew up in the era of maps, I knew that I could look at most states and know where most cities were, and I could immediately recognize mistakes on the United States map. I knew that those were mistakes. And here's what it has to do with this webinar. It started making me think about what can students not see like I can see? When they're in our mathematics classroom, what are our students, what's like Europe to them? What are they like not able to see in math that I can see because I have so much more experience than them? And so I want to challenge you in this thing to let go of how you see mathematics. And I want you to put on your student's brain. And I want to think about how we can support students in accessing math a little bit easier because they didn't all grow up like I did with mathematics, having a really rich experience. I got to see maps. I can read maps. I had a really great math experience. I taught a lot of students who had interrupted educations, and they're all looking at something that might feel really unfamiliar to them, like the Europe map felt to me. So when I had this epiphany years and years ago, I created a math planning goal for myself that I would create the experiences in my classroom that students would see it, the mathematics, before I showed it to them. And so I'm going to create things that they are excited to be independent and see things before I show it, and that they could say it before I would tell them. So I'm going to give you some examples of that. By the way, can you see it yet? Have you seen what's going on in this thing? I don't know if the smiley face in the chat is something that you're seeing here or in reference to something else, but I will answer the question before the end of the thing. So let's think about mathematics, and can our students see what we see? Like when students look at things in our classroom, like this is a poster that I had up in my classroom at one point for middle school. Can they see and look at tables and look at these words and look at arrows and look at all those things and see what I see? And I started wondering how students might read or misread each of the items below and what I could do to support that. So let's look at what's going on in the state of Minnesota. I'm going to tell you a little bit of the research. On the left is a reading text from 5th grade from the MCAs that you can find on the Minnesota Question Tool. On the right are 2 questions from the Minnesota Question Tool from the Math MCAs. I want you to think about the difference in what it takes to read the reading text versus what it takes to read math text. And how do we prepare students? You guys know, because you're from Minnesota, that we have in the state of Minnesota the READ Act, and we're working really hard across the state of Minnesota to improve reading for our students. I have a wondering though, are we nuancing that for content specific reading and thinking about math? So that's what this thing is about, because I would argue the left and the right require slightly different skills for students to be able to read it. We sometimes think reading is only about understanding the words, but there's some structural things that I think we need to consider. So one reason that our students struggle in math that the research says is they are trained in a Western way of reading from the top left corner is typically considered the starting point and is often carries the most visual importance. I wonder if that's true in math as well. Is the top left corner the most important? This is basically because readers typically scan a page from left to right and then from the top to the bottom. And so there's a hierarchy or a bias of what we read first and how we think about text. And we're so trained in this that we bring this bias to everything that we read. It doesn't matter what the content is, what we do. A lot of our students follow this hierarchy. In fact, this hierarchy is what our eyeballs do when we're not paying attention. They will go to anything and they'll scan across and they'll move over like a typewriter and come across and go back and forth. Now, if we have students that arrive to us from other countries, they have a different visual hierarchy. This is the hierarchy of the United States. In fact, there are tons of pictures that talk about the priority of where to place information. You can see that red category is where people tend to look the most for information. The yellow is priority 2, and the stuff in the green, you might as well just ignore. No one is paying attention to that as well. People who make websites know that 80% of the time that people are on web pages, they're looking at the left half of the page, only 20% on the other page. That's why they tend to put their menus on the left side of the page. So if we think about these math text, the questions that you saw before, and you take a look at the first one on the left, often when students are reading a problem like this, the most important thing they need to look at is the question, and that's in the middle of the text. And they don't always see it and don't always know what to do with it. And then they need to look at the answers and look back at this and then come back to the answers and then go back and come back, and their eyeballs need to dart back and forth. If you notice, the arrows I drew are different than our natural reading hierarchy for where our eyes go. If you look at the problem on the right, often to make sense of this graph, you need to look at something that's on the right side of the page. Something's in the side that we don't tend to put our eyeballs on. That's the 20% of the page in order to make sense of what's going on in the graphic. There are other ways that we give clues for reading. Some of those are related to color. This is like if you take a design class on how to design things for people to pay attention to, you can see on the left is one that's not as great, but the one on the right, the use of color allows your eyeball to go into what is different. In fact, there are 6 different ways that you can add visual hierarchy to the things that you design. Super important not to mix those things. So I started thinking about things that we design in math class. Like if I'm looking at this picture, this graphic, I'm like, my eyeballs immediately go to that worm. It's a different color. I also immediately go to the super large fish with the white teeth that are going after the little fish and all those things. And I started asking myself, what would a math hierarchy be? Like, how do we create these 6 things for math so that we support students in seeing what's really important to them? In fact, I think we just don't even think about this at all as math teachers. And then we wonder why students can't figure out what to do. They often stop at the top and it doesn't make sense and they give up. So how can you dismantle it and do something differently? Have you seen it yet? Can you see it? Are you annoyed with me yet that I haven't told you what it is? You'll find out soon. So let's take a look at some of these things, like how do you read these and deal with these items? So we're going to start with this one. I would love, just because I like to know if people are alive or not, I would love for you to put something in the chat. And if you're at home, stop and tell somebody that is nearby you, tell them something. What do you think students would do if this is the text that they were given? This is from a free online resource that you can get online. It's a sixth grade task. What do you think students would do when given this task? What are some things that they might look at? What might they see? Where would their eyeballs go? And so on. I love that someone's looking at the picture. I'm like, can you see it? And they said, is there a little pebble? That's the first thing I saw. That's not it, but that's definitely what I saw. Often when we give students texts like this, we give them some kind of mnemonic to like remember how to attach this. One of the most common ones that we see posters of in classroom is something called cubes. I'm telling you right now, if kids took cubes to this, they would be exhausted to circle all the numbers and all the units and underline the question, because there's lots of questions, and box all the action words and evaluate and eliminate. And they probably would lose track of all the things that are in here. In my first webinar in this series in October, the 3 reads, I gave you some ideas of how you could tackle this. But what I'm going to tell you right now is that a lot of times these mnemonics actually make it harder for students to remember than they like if the mnemonic is hard, we often make work for them that gets in the way of the other work that they need to do. I'm not a fan of cubes. I'm not a fan of a lot of the different ones we think. It gives a temporary feel to students, but it doesn't, and it helps with certain types of problems maybe, but it often doesn't help when there's more text like this one. And so how do we create for students the ability to read something first? And so one of the questions you want to ask yourself is, what do students see in this first? And I don't know if you know, I have done a little bit of study on this, and I happen to know a little bit. Not every student is the same, but as we're thinking about in general what students see, one of the things that students see is they see the question first. They have trained themselves in math, just look for the question, and they scan the first 2 paragraphs. They don't really read them well. They get to the question and they stop and they're like, I don't know how to solve that. I'm just going to wait for my teacher to tell me what to do. And they disengage. They might be compliant, but they don't really work to understand the text. You might think that they look at the table first. They often do not. That's because we're more sophisticated in mathematics and we're looking for clues there, but students do not. So how can we help students see what we want them to see first? How can we, before we assign anything to students, look through it and ask ourselves, what do we want our students to see in this first? What am I hoping that they will see first? I will tell you in a little bit what I would hope in this particular text that they will see first. But I'm going to tell you right now, when the questions are in the problem, your students often shut down. So one of my tips to you is remove the questions. Before you even have them look at the text, remove the questions and give them just a part of the text to start with. I don't read it for them. I don't have one person read it out loud. I'm just going to do some things that allow them to become independent of me to start to make sense of the text. So I remove the questions. It makes them safe because there's now not a race to an answer. There's not an answer to be found. And then when I remove the questions, this is the question that I ask. Hey, students, what's a question we might be asked about this information? So they're reading the information and then they're guessing what kind of questions they might be asked. And students might say, how many cups are there overall? They might come up with something else related to the things that they're doing. But them starting to guess what the question might be is actually creating the experience of them thinking about the context and the important information in the context. Another thing that I often do, and you would have seen me do that in that first webinar, is I remove numbers and I take them away temporarily because, again, when the numbers are there, they shut down and they don't think about the context of the problem, the structure of the problem that will help them solve the problem. The other thing that I've learned to do, and I do this almost all the time, I take things and I spread them out. I start a new sentence on a new line. I put a little bit of white space in there. It allows fragile readers to be able to take in bits of information. I don't know if you've looked at the reading test for MCAs, but they often put a new sentence on a new line in many of the texts that they give to students. It helps students rest their eyes and take in bits of information at a time. I also often add pictures or graphics so that they can be thinking, oh, I have 4 students, Priya, Han, Lynn, and Diego. And I'll put in pictures that give contextual clues of some things that are going on and allow them to make sense of that. Sometimes my pictures, this is for the second sentence, and this is a really, really, really common picture that I use, is I use a lot of talk bubbles where if students are saying things, I put them in talk bubbles, and we talk about how the students are talking to one another. Somehow that's more engaging for students. The exact same text, I just copy and paste it into a text bubble. But ultimately, if I had left it like this, my experience is a lot of students shut down before they even try. It's too much. And this is even good readers will shut down. It's just like, oh, I don't want to think that hard. And here's how I know good readers shut down. I'm a really good reader and I shut down. I don't even want to read this much text and do something with this. So I'm going to show you how I, in my own personal classroom, would approach this. If you were in my webinar last week, you would have seen this graphic for some routines that I use every day in my class. I use some type of safe routine. A safe routine is something where you can't get a wrong answer. And I'm going to show you how I would approach this text, not reading it out loud to my students, not having them read things. I would simplify this problem to start temporarily. And I would say to myself, Sarah, what do I want my students to say? What do I want them to know about this text? And there are 3 things that caught my eye. One was the word oatmeal. I wasn't sure that all of my students had ever eaten oatmeal, knew what oatmeal was, and I didn't want them getting caught up in that. I also knew that in 6th grade, we've been working on ratios. So I wanted to make sure that everybody was really clear with ratios. And I also thought that table was important for the learning in this particular lesson. They were going to get to unit rates, even though they've never studied unit rates before. So I knew that was important. So here was my first thing they did when they walked into my classroom with this task. Up on the board was this up here, and I asked that safe routine. What do you notice? What do you wonder? I had them stand up and meet with a partner for a minute, and they just named all the things that they could name. And students named, by the way, you might notice that the table has the labels covered up. I did that intentionally. You'll notice I put a picture of the oatmeal. Here's what it sounded like in my classroom. Hey, I noticed there's some rice up there. And I said, oh, yeah, it's not rice, but it's prepared very similarly to rice. How do you make rice in your house? And they told me that they got water and they rinse the rice and blah, 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 blah. And they do that. Sometimes students would have made cream of wheat or something else. Maybe someone has made oatmeal, and we talked about how do you make oatmeal in just a few seconds or so. I said, if that's oatmeal or rice, what do you think the titles to the table would be? And they often guessed these before I even told them. That's my planning goal, get them to say it before I tell them. Then some student in my class said, we've been working on ratios. And I'm like, oh yeah, ratios, comparing 2 things. Ooh, look at me, I'm pairing language. We're comparing 2 things. What do you think we're comparing? And they're like, we're comparing how much water we need depending on how many oats we're using to make oatmeal. It looks like the first one, they're making a lot of oatmeal, Miss Van. They must be making it for a whole school to have that much oatmeal. And they talked about how there's a comparison, and they talked about that we could write ratios like this. And they said the word ratio before they ever read the word ratio. And they talked about that there were 2 ways that we have been working with it. And I'm recording everything that they're saying. And they're like, Miss Van, why is there all these ones? And I'm like, oh, pay attention to those ones. They're going to be important for something that we're doing today. All of that took about 3 minutes. Rather than reading it, I just took this and got them to say the things that I wanted them to notice in the problem. And then when they went to the problem, I said, I'm going to give you 2, 3 minutes to read it on your own. And then you're going to get started with a partner. And sure enough, students maybe didn't know how to do everything, but they knew how to get started. They had enough stuff in their bucket to start making sense out of the problem. There's no perfect way to start a problem. But reading and math requires you to not just read words, but to read numbers, to read charts, to have a question later on that you need to go back to the prior information and you want to toggle back and forth. And that's not something we naturally want to do with reading. We just want to read something once and get the main idea and move on with our life. Another thing that I do a lot is add visuals, especially if it's contextual, something that they might not know. And removing details, super important to me. So I'm just going to show you some examples of things that I've removed details from. I've shown this one before. I found this graphic for a probability unit that I was doing. And I was like, woo, too many words. And I know you might be thinking there's not a lot of words there. Yes, there is. If you give this many words to students, they will not read them. They'll just be like, that's nice. I'll glue it into my notebook. And they're super excited, but they really haven't engaged. Instead, I remove all the words and I give them this instead and say, what do you notice? You know what students do every time when I've given them this picture? They say almost all these words. They even guess what the definition of is, and they talk about those decimals and they turn them into fractions and do a whole bunch of things from them. Here's a graphic that I found when I was trying to talk about teach how to find the mean of something. I was a middle school teacher for a long time, and students started talking about the average height, and we guessed which player was the average height, and we made some preconceived, and I said, what do you think we would do if we were trying to figure it out? And we did a lot of things. Then I gave them information about the student's height. Well, by that time, they had already made some pretty good guesses. So I temporarily removed things. I'm not going to spend a ton of time on here, but if you've never done the Noah's Ark cast from Fon Win, you should totally check it out. I remove all the words, just look at the graphic. It's my favorite first week of school task to use middle school and high school. I also taught a lot of high school. And when I was introducing the idea of a feasible region in a system of inequalities, I use this, and you cannot imagine how much stuff students could say about this picture and tell me things that were going to be important and which of these different functions went with each inequality and so on. A common question that I ask when I remove the details is, what's a math question we could ask about this? It's amazing how many great questions they come up with for this. What are the intercepts of the parabola, the U-shaped curve? Can we find the point at the bottom, the vertex, the coordinates of the vertex, the X and Y values of that vertex? I don't always get it right. We were working on transformation of functions and looking at the basic functions y equals x squared. And we're putting the values of the points that make these up and looking at the relationship. And students were just writing things down, but not really thinking. So the next day I came in with a graphic look like this, and I had taken away some of the visual noise of the graphics. I didn't even have axes on here. I guess I do with that purple one. Well, those aren't even axes. Those are, well, I'm not going to go into math right now. But I gave this out and let students just play around with it a little bit. Woo, the amount of stuff they came up with to look at a relationship, at how the points are related to each other, and then what happens when we transform them in some way. We use some kind of dilation or translation or whatever, was just amazing. In fact, they begged to have this graphic on their test. And I'm like, there's not even anything that interesting on the text. I would have thought they wanted all the numbers. Nope. Here's what I've learned. If students are struggling, I'm often giving them too much information for them to read at once. Their eyeballs need something to do something with, and I work to change some things. So let's look at some of these things that I had in my original graphic, and we're going to start with this one. I have two students, and student in the pink or blue said 3 is greater than 4, and the student in the pink is like 4 is less than 3. And the question is, who's right? Well, if we take a look at who's right, the answer is they're both right. So one of the things I want to talk to you about when you think about this is there's this misconception that we always read from left to right. And in order to dismantle that, we, the teachers in the space, need to read our equations, read our inequalities forwards and backwards. I often do backwards first because students are like, that's not right. And I'm like, why is it not right? I will turn them around. I will read them back and forth. I will have them practice reading them back and forth. When we always read things one direction only, students don't develop the flexibility they'll need as they enter higher levels of math to make sense out of information. Here's another example where students struggle, and it's not their fault because it's us, and honestly, it's children's books that they read, shapes books that they read when they're growing up. These two students were asked to find the area of this shape, and the two students gave these answers to how they found the area. And here's some things I noticed about the two students. Both students have a good idea of how to calculate the area of a triangle, base times height divided by 2. They might have reversed a base and a height in their order, but commutative property multiplication, that's okay. Not a big deal. They both identified the height of the triangle correctly, 4.8, and they both have that in their calculation. But the two students have different bases that they put into things. The student in pink actually has the wrong base. 6 is not the base of this triangle. But the number of students who think the base of a triangle is the bottom of the triangle, they have a misconception that the bottom of a triangle is the base, is ridiculously high. Most students think that is that, so much so that I never make the base the bottom because I'm trying to undo like this pattern that they've noticed that things that are on the bottom are the base. I think it has something to do with the word base often refers to the bottom of something. But one of the things that we can do to battle that misconception is to orient our triangles in a lot of different directions when we draw them. And so I often will turn things around. I'll have students actually rotate their paper in other directions, because if they want the base to be at the bottom, I'm like, no problem, just turn your paper so that it's at the bottom. But what are the things that we're doing to support them so they see that base is not always the bottom? And so I have a lot of graphics in a lot of different ways that I support that. But our students don't just look at something and see bases. It's something that we have to write and label and highlight and do over and over again in order for them to do well. This is true with three-dimensional shapes. Again, what do? I rotate them, I turn them on the corner. I don't just give the standard way. In fact, I often don't give the standard way first. They already have that embedded in them. And then it's really important with this, students want the bases to be the top and the bottom of a prism, but they also want the height to be vertical. They don't like when the height is horizontal. And guess what? Sometimes heights are horizontal and they're still called the height. And so it's something that we have to dismantle. And if we're not using lots of different orientations of the things, this is really connected to one of the 8 math practices that I did webinars on earlier this year, math practice 6, attending to precision, because it's our language that also has to always be there. Prisms have bases, but they're not always the bottom. The bases of prisms are 2 parallel congruent faces that the shape is based upon, and making sure we have precise definitions. All right, let's look at something else. Here's a student that's saying, my teacher keeps saying distribute the 1, but I don't see a 1. Where is the 1? I don't see a 1. And when you're looking at that, there isn't a 1. It's invisible, but there is, I call it a ghost of a 1 that is sitting there. It's invisible. I often early on will draw a little ghost for my students. When I say ghost of a 1, and by the way, I'm not the only one. I Googled this. This is something that came out of Google. A ghost of a 1 really is referring, and I will name this. I'll say, yes, there's a 1. The multiplicative identity is when we multiply anything by 1, it remains unchanged. So we don't always have to write it. And so sometimes I call that a ghost. A lot of times I don't draw a ghost. I just make the one in dotted lines, and you'll see that in a future slide. When you look at this expression, I'm going to spread it out a little bit. There's actually a lot of ghosts of ones in this. There's the one that's right there that the teacher was talking about. There's another one in front of the whole expression. There's another one in front of there. And then there's ghosts of ones that represent the exponents that we don't write. And then there's a denominator to this whole thing. You'll notice that dotted line for the denominator line. And we have a 1 in the denominator. When I started making visible the invisible things that they can't see, all of a sudden the outcomes in my class related to this changed. I write in invisible numbers all the time and I call them, hey, what are some numbers that are invisible? What are we not seeing? I don't always write them in, but I often write them in because if it's going to help a student who's struggling for me to write a 1, that's okay. Almost all of these invisible things are related to the algebraic properties. And I don't think that we spend enough time on the properties. If you look down there, the multiplicative identity property, there is a ghost of a 1. In the additive identity property, there's a ghost of a 0. There are zeros all over the place that we just don't see. And it's really important that we name these properties when things are invisible. Here's an example of the commutative property for addition and multiplication. I guess I'm just showing you addition right here. But a student can say 3 plus 4, and I'm like, yes, we can read this 3 plus 4. But another student might say, yeah, this is 4 plus 3. And I'm like, you're absolutely correct. Because of the commutative property, we can reverse this and or say it forward and backwards. With multiplication and addition, we can read expressions forward and backwards with no problem. Again, forcing myself to name the property, use precision, and talk about things that are not seen. So let's practice a little bit. Where are there ones in this expression? Because there's some ones that we don't see. There's some of the ones that this student is seeing, but there's also zeros. Do you see any ghosts of zeros, invisible zeros that you can't see? Well, we could turn these into decimals and there'd be some zeros that would follow after them. And there's some other invisible things. We don't always write all the things, and those zeros would continue. But our job as teachers is to make the invisible visible. This is really a lot like something that you would see in my classroom, where I'm talking about the properties that I'm using to create zeros. I also often don't cancel things out. I put a big 1 there so that we talk about taking out a factor of 1 out of the equation. Again, always making visible the invisible, the ones. By the way, there's a lot of teachers that have created posters for these. I even think I uploaded one of the sets of posters into the folder for you if you're interested, where they have students take a look at these. I'm not necessarily a big fan of these. I bring them in when it's important. Instead, I just like to make those things come alive to them. Here's another thing that students like give up on related to mathematics is they will ask something like this. Hey, Miss Van, is it a negative X or a minus X or subtract X? I'm so confused. I don't know how to read this. They really struggle to read things that have negative signs and or we're subtracting something or finding the difference of something. In fact, these aren't the only ways we talk about this. And depending on which of these symbols we're looking at, there might be a couple of these that are correct and some that might not be the best choice for this. And then there's other words that also could be used in this thing. So as you're thinking about attending to precision of language, really think about how you do that with students. My way of doing this is not just to say it, but to write the words that would go along with each of these for my students. Let's look at some other misconceptions and some of the invisible things that make math really, really hard for students. Here's 2 really common misconceptions that we see in students. On the left are 2 problems that they were being asked to solve. On the right is their solutions to them. In the first one, they were asked to substitute a 3 in for the variable m. And you can see instead of doing 4 times 3, they made that number 43 and added it to 8. actually more common than you would believe. The next one, also really common. They're working with function notation. In this case, they did substitute the 7 correctly and did 3 times 7 and got 21. But when they got to f of 7 equals 30, that's not how they read it out loud in their head. They thought they were trying to solve for f. So they divided both sides by 7 and said f is equivalent, is the same as 30 over 7. So how do you make sure students aren't doing this? Well, let's take a look at the first one. The first one is because of some invisible multiplication signs that aren't always there. I have 2 examples of things that I see students really struggle with, because not only can ones and zeros be invisible, but operations in math can also be invisible. And so I'm always, especially when I know even a few of my students are fragile with this, I am at the beginning of the year going to make a little ghost and say, woo, before we substitute, before we plug in that 3 into the equation, let's make sure that we know that there is an invisible multiplication symbol between those 2 things. Over here, same thing. Students don't always see a set of parentheses as multiplication. And so as we're thinking about this, I am going to put that multiplication symbol in there. Might make a ghost. I don't always make a ghost. I'm going to talk about how we're going to multiply it with everything that's in that parentheses and going along with that. And then we're going to do the mathematics and do things just fine. By the way, when I get the solution to the second one, I'm even going to go in and put multiplication symbols, even though they're not necessary, and say, there's just an invisible multiplication symbol. I either do it in a different color. I might do some other things. It also encourages me to be really careful about my language. A word that I use forever in my career is I would talk to kids about canceling out things, canceling out the 4, canceling out the 3. It's actually not great language, and I'll talk about a little bit or show you a book that you can read if you're interested in learning a little bit more. But if you take a look at the thing that we have in orange, a better choice, I want to minimize saying cancel out the 3s. Instead, I want to work on improving saying and being more precise. We're eliminating a factor of 1. By the way, I'm almost always going to also write in a division symbol for that fraction bar. I'm going to write this down. And if you look at the bottom there, that dotted 1, that's often how I make a ghost to the 1. But instead of putting a line through things that I cancel out, I will actually put the number 1, or I'll put a number 0 if that's what they're creating. Here's another example of things that are invisible when it comes to notation and operations. This is a really common question I ask secondary students. Find the mean, the average of these numbers. And students will immediately grab their calculators and they will type it in and they will say, Miss Van, the mean is 42. And you might be wondering, where did they get 42 from? Well, this is what they typed into their calculator. The calculator knows the order of operations. And so the calculator took the 10 divided by 5, got 2, added the 4 other 10s and got 42. It's another reason I don't like them. Please excuse my dear Aunt Sally, is because really what they were missing is that when we have a fraction, like you see in the middle there, there's some invisible, I'm putting them there in dotted lines, parentheses that surround the numerator, the top of that fraction. And if you take a look at that, you can see some things. And so one of the things I like to do is eliminate that. Instead, talk about grouping symbols but really have experiences where we draw them in and create the experiences so we can get the correct solution. By the way, I don't even know why they grabbed a calculator to start with. They don't have a concept of average if they even grab the calculator to start with, but that's a whole nother video. By the way, if you want to hear things that I've changed my language on, I once made this graphic and I uploaded it in the folder and wrote about it, where in orange are the things I changed to saying and what I tried to get rid of and minimize was in black. It's not just me. Karen Karp and some others have written a series of books called The Math Pact. And she says when we use language incorrectly and inconsistently across our school, that's another danger that one teacher says one thing, another teacher says another thing, students are harmed. And so there's this series of books for elementary and middle school and high school. And in them, they talk about, um, give a lot of examples of things. For example, they talk about words that have expired, might have worked before, but we want to consider using other words as we're going along with that. So all of these things are resources for you to go and consider. What I want to do is spend just a little of my remaining time talking about tables and graphs. Remember, the priority is given to that upper left-hand corner when we're reading, and often graphs are located in different parts than that, and they don't always get the attention that we want. So if you were in our trainings last summer, we gave you a routine that has tons of free resources for reading graphs. It's called Slow Reveal Graphs. I've linked to it, or maybe I haven't linked to it yet, but I will link to it. And in Slow Reveal Graphs, what you do is you take a graph and you remove a lot of the information, and then you start asking questions about the graph. And so you say, what do you think this graph is about? The goal is for them to see the structure. And students will say, there's things going up, and then they're going down, they're going up again, and then they're going down. And you ask, what do you think is going on in this graph? What do you think it might be measuring? And they say, oh, there's 12 things. I wonder if it's months. And you reveal some of that information to them. And you slowly give them information. What might be really low in June, not have a lot, but there's a lot in March. Any guesses what this might be about? And students will start to think about what the axes might be labeled. And rather than bringing their eyeballs to the top and reading a graph from top down, you're forcing their eyeballs to jump around the graph and answer questions to understand the structure that's there. This happens to be returned salmons in a river in the year 2013. And then you want to do, and I do this with every graph for a long, long time, ask them a question like, how many salmon were there in April? And have them draw on their graphs or get out a ruler and help their eyeballs go over. That's not the world's straightest line on my computer, but drawing in some straight lines so they can read those things. If you're interested in this, we did a whole training on this for the first anchor standard. If you don't know this site, this should be your summer reading. Slow Reveal Graphs. Jenna Labe, who's the person behind this, she has given you PowerPoints and all kinds of things where she's done all the work to give you a graph that's kind of interesting, to remove the information for you, and then to animate it and put some questions that you could talk to students. What relationships do you see between the bars? And then you give them a few numbers that are on the bars. What new information did we learn? What do you think the other values could be? And have them make guesses what the other bars might be. After they've had 3 or 4 minutes, give them some of the bars and say, hey, did you get these correct? How about the bottom two? Any guesses what the bottom two might be? If you're watching this video right now, pause it and guess the bottom two. What do you think is the number that's going to be on those bars? I added those numbers. How were your estimates? What do you think this is measuring? Oh, we have some evidence at the top. There's a dollar sign at the top. These are actually countries. What do you think this graph might be about? And all of this I would do over the course of 10 to 20 minutes with students. I'm speeding through it now. But Jenna has done a ton of work. You don't have to do this, but you're training students how to look at information. By the way, I love this bar graph because it's horizontal and it's not vertical. Again, going to having flexibility. By the way, this is a really sad graph. How much government spend on childcare for toddlers? If you look, the United States is the very bottom at $500. Boo hiss. Boo hiss. Anyways, here's what Jenna Labe said. Graphs are text to be read. It's an active process. In order for us to be effective sense makers, we need to break that graph down. We need to analyze, make guesses, conjectures, test our guesses and our conjectures, reevaluate, but really engage in sense making. It's something that we need to teach them. When I have graphs, another thing that I do is use some of my safe routines. Two of my favorites with graphs are, what do you notice? What do you wonder? But tell me everything you know about it. If you were in my webinar last week, you would have heard me talk about this. What do you notice about this? What do you wonder? Tell me everything that you know. Students, my goal is that students would see the structure of the graph before I even give them the task to solve. When I've given this, students have said, oh, I see that 5, that x coordinate on the x-axis. You could take that down, and that means this is probably being scaled by 5s as well, just like the y-axis. And as they're talking, I'm annotating. And before I give them the question, we're seeing a lot of structure and we're making a lot of meaning of that graph. So our goal as teachers in mathematics is to really dismantle left to right thinking, because a lot of mathematics is not done that way. And I'm going to give you my very, very, very favorite routine to kind of close us out. And then I'm going to tell you what it is in that picture. So my favorite routine is what's the same and what's different. I love to give students 2 things because it forces their eyeballs to go left and right and left and right, sometimes up and down, to compare the things in the graph. They will see amazing things and say they have different up and down points, vertices. And so I will highlight them and name them, but they have the same y-intercept, and we will name that, and we can keep going. And I give students things. It allows their things. They're comparing this. They're comparing this. Their eyeballs are going all over the place and making meaning. They're coming over to the key if they don't know what it is, reading the labels, and we're training them to do things. There is nothing better than you could do than ask kids to compare and contrast. If you've ever had a problem with students using a protractor, you want to come and steal this graphic from this thing. Best thing I ever did is, I don't know if you struggle with protractors, but students being able to read things left to right and right to left and realizing you can do it both ways, it can be sometimes overwhelming. So rather than me telling them how to use a protractor, I use this and have them tell me what they think is going on. And we have a lot of good discussions. When we're making tree diagrams in probability units, if I only give them one tree diagram, it's not as good as giving them 2 side by side. One, in this case, one has, we're drawing on a marble, but we're not replacing it. The other one, we are replacing it, and how that changes the outcomes in each of the branches. Same and different is my favorite way to define words. These are polygons, these are not polygons. Students' eyeballs have to go back and forth to compare what's the same and what's different. They say all of these things, and then I say, go define a polygon. And everything you see in green here is enough for them to write a really phenomenal definition of polygon. So rather than me giving them a definition, by the way, this was created for 3rd grade by Marilyn Burns. And it was created 30 years ago. It's not a new thing. I was teaching high school and wanted them to know what a polynomial was. So I asked myself, what do I want them to see? And what do I want them to say? And then I put a bunch of examples on one side, non-examples on the other side that would help them say those things. And I gave them these things, and students saw all of this stuff. So if you want to have students define things, make your own. Put examples on one side and non-examples on the other side. And the way you figure out the examples and non-examples is put things that will help them see things that are the same or different, that are things that are part of the definition of what you're doing. So there's a whole bunch of examples of same and different in here. Just for time, I'm going to go past it. Tables, make sure you're not just making tables vertical, make sure you're making them horizontal. Make sure you're not just using tables that have 1, 2, 3, 4, 5. That first table, by the way, is something called a ratio table. It is key for middle school mathematics and developing proportional reasoning. If you don't know what a ratio table is, Google it. Students have to be looking at tables across, but also going up and down. Tables don't have to have just 2 columns. Make sure you're doing things a lot. This is a really cool link that I was sent this morning where people are having them compare. Like, my tip is just have students compare things if you want them to develop reading skills in math, because their eyeballs will go back and forth. This is a whole bunch of GeoGebra things where students can check their work to review mathematics. When you click on D, which is the right answer, and then click check, it actually has a little race of the cars. I didn't have time to film it, but you can see the cars racing. The orange one finishes first, and they give you the answers to it. It allows them to do a lot of other things. So there's a lot of other really cool stuff in here, but just for time, I'm going to go past a bunch of stuff that's in here. But there's a ton of stuff that we could do related to how to read things like equations and so on. You have my slides, so you can go in and take a look at those. If you want me to go more slowly in the future and talk about types of number lines, make sure you're using vertical number lines, because that's how most real number lines exist in the real world. Make sure you don't always have 0 in the center or on the end. My favorite number lines are not number lines that pre-come with numbers, that they are open, and we use them as thinking documents. And double number lines are huge if you're comparing anything. And if you've never heard of clothesline math, best kind of number line I ever did in my classroom. And you can use this all the way down in kindergarten, all the way through high school. And you can Google it. There's lots of research out there on that. So if you remember, I showed you Duluth in the wrong place. And I asked you to think about, what can't our students see? What in math class is like Duluth for them? It's in the wrong place, but they just can't see it, and they don't know how to do it. And what am I going to do as the educator so they can see it before I show them that there's a problem? This is my planning goal. And this is, as you're thinking about how to read in math, I want you to really think about the hierarchy that your students are coming in with class. Think about how you can dismantle it. By the way, I don't know if any of you saw this. And I'm going to show you what's there, and there's a reason for it. If you look right there, there's a cigar sticking perpendicular outside of the wall. Right there where I've highlighted in yellow, if you look, there's a cigar sticking out from the wall. I never saw it. I just thought it was a crack. That right there was a crack between the bricks. Nope. It's a dark brown cigar sticking out of the wall. The end that someone probably thought was a little pebble or a face is actually it's a lit cigar, and it's there. Why am I showing you this? Because if we can support students in reading, once they see things, you can't unsee it. Once you see that cigar, for the rest of your life, when you see this picture, the first thing you will see is that cigar. It can be hidden forever, but as soon as you see that thing, you can't unsee it. And that's what we want them to do with mathematics, is we want to make this so obvious for them, empower them to see these things that they will never be able to unsee it in their life, that they won't go to a test like this and not see the inequality symbols and answer all these questions like this. So everything that I've shared with you today is in the folders. I have a few links that I'll put in there on slow reveal graphs and a few other things, probably like some clothesline math in the next couple days. But if you want to get anything that I shared with you today, it's in there.